Now, in this video, we will going to take up one more problem on Pentagonal Lamina, how to analyze this problem in 3D and how to solve by using the manual sketch or by using the sketchbook. A pentagonal lamina of edges 25 mm is resting on one of its edges on HP with corner opposite to that edge touching VP. The edge parallel to VP and the corner which touches VP is at a height of 15 mm above HP. Draw the projections of the lamina and determine the inclination of the lamina with HP and VP and the distance at which the parallel edges lies from VP. So, a pentagonal lamina of edges 25 mm is resting on one of its edges on HP. So, that means you are starting the problem from HP, that is from the top, with corner opposite to that edge touching VP. So, which is the always you remember in an odd number side, edge opposite is always a corner. So, but he says the corner, the edge opposite on the edges on HP with corner opposite to that edge touching VP. So, that means he has given in the third position. The edge parallel to VP and the corner which touches VP is at a height of 15 mm above HP. So, then draw the projections and determine the inclination of the lamina with both HP and VP. So, since the inclination has to be found out for both HP and VP, so obviously we need to write the profile view for this type of particular problem. Always you remember, whenever the inclination has to be found with respect to both and HP and VP, always you remember that we need to write the profile view, because when the surface is inclined to both end HP and VP, then that profile will be, then that surface will always be perpendicular to the profile plane. So the determination of the inclination is possible only when it is perpendicular to a plane. Now we will see how this will going to work with the problem. We are going to analyze it in detail. So as we know that he says it is one of the edges is resting on HP. So obviously the initial position has to start from the HP only, that is from the top. So here first you draw a pentagon of 5 sides such that one of the edges is perpendicular to VP. You can see that this is the edge which is perpendicular to VP. So the side opposite to that is a corner. So that means when you look from the front view, since the surface is perpendicular to VP, so you are getting a line in vertical plane. And here, as we look from the front view, all the sides are resting on HP. That means A dash B dash, B dash C dash, C dash D dash, D dash E dash and E dash A dash. All the sides are resting on HP. Therefore, it is parallel to HP. Since it is parallel to HP, so in HP we will going to get the true share. That means AB equals BC equals CD equals DE equals EA, which is equal to 25 mm. And now, so AB is, since A dash B, AB is inclined to VP but it is parallel to HP, therefore you are getting the true length here. Similarly, BC is inclined to VP and it is parallel to HP, therefore you are getting the true length here. Similarly, DE and EA, but whereas CD is parallel to HP and perpendicular to VP, therefore in vertical plane you are getting a point. So this is the corner and this side is the edge. Always remember, whenever you have a corner you are going to get 1 point, whenever you have an edge you are going to get 2 points at the end. So this is how you will be able to analyze the first position in the initial position of the object or the pentagonal lamina when you are considering on both VP and HP. Now we go to the how to write this in orthographic view. So draw the XY line and you mark VP and HP. So you measure a distance of 25 mm in the vertical direction, that is perpendicular to XY, and you mark this point as C and D. By using the protractor with C as center with respect to CD, you measure an angle of 108 degrees with respect to this vertical line. And from there, you draw a line inclined at 108 degrees with respect to the vertical. Similarly, with D as center, with respect to this vertical line DC, you measure an angle of 108 degree in clockwise direction with respect to CD and you draw an inclined line. Then you take the compass, you measure the radius of 25 with C as center, cut an arc on this inclined line. Similarly with D as center, cut an arc on this inclined line for the same radius. Now you mark this point as B and E. With B as center, take the same radius of 25, you draw an arc. With E as center, cut on the previously drawn arc. So now you got the 5 sides and you mark this point as A. Join A to B, B to C, C to D, D to E and E to A with a dark line. Then from A you draw a vertical line to the XY line. Similarly from B and E you draw a vertical projector to the XY line. And similarly from C and D draw a vertical projector to the XY line. And you mark, as you look from the front view, A, B, C is near to the observer, therefore A dash, B dash, C dash is visible. So similarly here, as we look from the front view, A, B, C is near to the observer, so A dash, B dash, C dash is visible, and D and E is away from the observer. That means D is coinciding with C, and C is hiding this point D, and B is hiding this point E. Therefore, E dash and D dash will going to be invisible, so you put it in bracket. So, what is the position? All the sides are resting on HP. So now the sides are parallel to HP. So you are getting the true shape in HP. And the surface is perpendicular to VP. Therefore, in vertical plane, you are getting a line. So this is how you will be able to write the initial position of the pentagonal lamina, both in the front view and also in the top view. Now, then the edge opposite to the corner is above HP by 50 mm. So he says. So it is resting on one of the edges on HP. So you consider one of the edges is on HP, that is C dash D dash. So here CD. So now the corner is also resting on HP. Now what you want? You want this corner to be above HP by 15 mm. That is what we have shown here. The corner is above HP by 15 mm. Then where CD, the corner opposite to this is the edge, is resting on HP. So this corner is above HP by 15 mm. So as that means you are rotating this first position top view such that A is above HP by 15 mm, whereas CD is on HP. So when you are rotating this in space, what happens to the front view position? The front view position is rotated by such certain angle such that corner A dash is above HP by 15 mm. How to do that now? So to take any convenient distance, then you just you rotate this by such that A is above HP by 15. Then you project these points vertically here to the VP, and from B and D you will going to get this point. Similarly from A you will going to get this point. So you got this line. Similarly, draw a vertical projector from A, B and D to the XY line, to the HP. Then you mark this as small a, small b, small c, small d and E. Then join A to B, B to C, C to D, D to E and E to A with a dark line. So what is the position of this surface with reference to both VP and HP? So the surface is inclined to HP, but still it is perpendicular to VP. Therefore, you are getting a line in the vertical plane. Then, how to write this in a two-dimensional sketch? Now, you take any convenient position between C dash and this C dash, D dash. You take any point, you mark that point as C dash and D dash. Then, from XY line, you measure 15 mm and draw a horizontal line. Then, you measure the distance from C dash to A dash by using the compass with C dash as center, cut on the previously drawn line, horizontal line. So you mark this point as A dash. Then join A dash C dash with a dark line. Then you measure the distance from C dash to B dash with C dash as center, cut on this inclined line. As you know, this is B dash and A dash. You mark those 2 points B dash and D dash. Then what I need to do, now I need to write the top view. How to write the top view? Draw a vertical projector from A dash and draw a horizontal projector from A. Both these two lines will going to intersect at this point. So you mark this point as small a. Similarly, draw a vertical projector from B dash and E dash, and draw a horizontal projector from both B and E. Those 2 points will going to intersect at these 2 points, and we mark that point as B and E. Similarly, draw a vertical projector from C dash and D dash, and draw a horizontal projector from D and C. Both these 2 lines will going to intersect at these 2 points. We mark this point as C and D. Then join A to B, B to C, C to D, D to E, and E to A with a dark line. So this is how you will be able to reproduce the second position top view. Now here, if you see that the surface is inclined to HP, but still the surface is perpendicular to VP, therefore you are getting a line in the front view. And here, since C dash D dash is parallel to HP, therefore CD is in true length. What is the true length of this line? The true length of this line is 25. Here also you will going to get 25, and here also you will going to get it as 25. Whereas A dash B dash, B dash C dash, C dash E dash, D dash E dash, E dash A dash, all are inclined to HP. So none of these 4 lines will be in true length. That means it will be less than 25 mm. So this is how you will be able to get this. The side opposite to the corner is resting on VP. So here the side resting on the side of the corner opposite to the side is above HP by 15. Now it has to be on VP, but now at this present juncture this corner is in front of VP. So if you want to take this on to VP, what should I do? You rotate this in a clockwise direction and keep the point A on the vertical plane. Now you see that how it has been done here. So you rotate this the surface which was inclined such that A is above HP by 15, and you keep that on vertical line, on vertical plane. So that means A dash is here. Then you, with the same inclination, you have A dash, B dash, B dash, A to B, B to C, C to D, D to E, E to A dash. So this is how you are going to get the surface. But how to get it to the top view? When you look from the top view, A will be on XY line. Then draw a vertical projector to B. You will going to get it on HP. E will going to get it on HP, and C and D is already there. So you join A to B, B to C, C to D, D to E, and E to A. Then when you write it on, when you look from the front view, A dash is here. This B dash will going to be projected here, and this E dash will going to be projected here, and C and D are on XY line. So C dash and D dash will be on XY line. So you then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and E dash to A dash with a dark line. So this is how you will be getting the image in the vertical plane. The side is resting on HP, while the side opposite to the corner is resting on VP. So once the surface is inclined to both HP and VP, obviously that surface will be perpendicular to the profile plane. So when you are looking from this, since it is perpendicular to the plane, therefore in right profile plane you are getting this as a line. So as we look from the left side view, A double dash will be on VP, and C double dash and D double dash is on HP. And as we look from the left side, C double dash is visible and D double dash is invisible. And as we look from the left side, B double dash is near to the observer, it is visible, and E double dash is away from the observer, it becomes invisible. So theta is the surface inclination with respect to HP, and phi is the surface inclination with respect to VP. The sum of these two angles should always be equal to 90 degrees. So this theta will be equal to this theta which is inclined to HP. So this is how you will be able to analyze the problem in 3 dimensions. Now how to write that in 2 dimensions we will see. So the next thing is, so I want to keep this point A on vertical plane. So how to do that? So consider any distance and you mark that point A on the XY line in the top view. And from here, so you reproduce the same sketch here. How to do that? From A, draw a vertical projector downwards. Then you measure the distance from A to this line by using the compass. From A, you cut an arc on this perpendicular line, and through with this as center, draw a horizontal line through this. Then you measure the distance from this point to C and also from this point to D. Both will have equal distances, and transfer this from this point to C on the left hand side and from this point to D on the right hand side by using the compass. Then you mark this point as C and then you mark this point as D. Then you measure the distance from this point to here. Similarly, you transfer this from here to here, and with reference to this particular line, you draw a horizontal line. Then you measure the distance from this point to B and also from this point to E. Both will have equal distances, and transfer this from this point to B and also from this point to E. So you mark the point as A, B, C, D, E and A. Join A to B, B to C, C to D, D to E, E to A with a dark line. Once you do that, now I need to write the front view. So to write the front view, draw a vertical projector from A to the front view, draw a horizontal projector from A dash. Both these two lines will going to intersect at this point. You mark this point as A dash. Similarly, draw a horizontal projector from B dash and A dash, and draw a vertical projector from B and E. Both these two lines will going to intersect at these 2 points. You mark those 2 points as B dash and E dash. As we know that it is C dash, D dash is on XY line, draw a vertical projector from C to the XY line, similarly from D to the XY line, and you mark these 2 points as C dash and D dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to A dash with a dot line. Since this is the surface, you got the surface here also and here also, therefore surface is inclined to both HP and VP. Obviously, you will going to get the profile plane. So take any convenient distance and draw an x1, y1 line, and then mark these points as x1 and y1, and you mark this as the profile plane RPP. Then with reference to the origin, measure an angle of 45 degree with respect to the xy and draw an inclined line, 45 degree line. Then draw a horizontal projector from A to the origin, and from here draw a vertical projector, and from A dash to join these two, you mark this point as A double dash. Similarly, draw a horizontal projector from B and E to the A 45 degree line, and from this point you draw a vertical line to the profile view, and then draw a horizontal projector from B dash and A dash. These 2 lines will going to intersect at this point. Similarly, you mark them. Similarly, draw a horizontal projector from C and D to the X 45 degree line. From there, you vertical projector to the XY line. As you know that C dash, D dash is on XY line, you project this to the profile view, and both these 2 points will going to intersect at this point, and you mark, as you look from the left side view, B dash and C dash is near to the observer, therefore B double dash is visible and C double dash is visible, whereas D dash and D dash is away from the observer. So because that E dash is coinciding with B dash and D dash is coinciding with C dash, therefore E double dash and D double dash is invisible. That's what we can see here. As you look from this view, B is visible and E is invisible. Therefore, B double dash is visible and D double dash is invisible. Similarly, C is visible and D double dash is invisible. So, once all these 3 points will going to lie on the same line, then join between A double dash to C double dash with a dot line. By using the protractor with reference to the C double dash, with reference to the XY line, you measure this angle which is equal to theta, which is 23 degrees, and by taking the protractor on this x1, y1 line with A double dash as center, with respect to the x1, y1 line, you measure in counterclockwise direction, then this angle will be 67 degree. Then you measure the distance of the edge from the vertical plane. That distance will going to be L. So when you measure that, it will going to be 35 mm when you are doing it in manual. But when you are doing it in computer, you will going to get up to the second decimal point accuracy. The dimensions what I have given is only for the sketch which is been done by manually. The sum of this theta plus phi will always be equal to the complementary angle, which is equal to 90 degrees. So this is all. How do I know that my problem is right? So here, one of the edges is resting on HP, the side opposite to the corner is resting on VP, and the distance of this point from the extreme edge is the one which we need to find out. And then the corner opposite to the edge is above HP by 15 mm, and this is a pentagonal lamina of 25 mm size. Since all the data which was given in the problem we have considered here in solving this problem, and hence our problem is right.